Hello, everybody. Now that we know a little something about what a tangent line is, now let's turn our attention back to different types of angles formed inside the circle. Quick review of what you should know so far about angles inside the circle. Day number 2, we talked about this type of angle, which is called a central angle. And if you guys remember, a central angle was always equal to the measure of its arc, right? All right. Day 7, we said, all right, well, what happens if the vertex is not the center of the circle, but is now on the circle? This is what we refer to as an inscribed angle. And an inscribed angle is not equal to its arc, but it's equal to half its arc measure. All right, so those are the two angles you now know about inside a circle. Well, let's think. I have an angle where the vertex is the center, an angle where the vertex is on the circle. There's one more type of angle where, what if the vertex is just kind of floating inside the circle somewhere? It's not on the circle and it's not on the center. All right. I want to introduce you to what we're going to be calling a floater angle. Okay, where the vertex is just floating inside the circle where it's not on the center. So for instance, I'll just pick one right now in my circle here, angle DCE. We refer to as a floater angle because vertex C is not the center, it's just floating inside the circle. Okay, and there's 3 other ones around it as well. All right, I could have picked ACD, ACB, or BCE. They're all floater angles. So now how do I find a floater angle? All right, this is your only theorem, I believe, for today. A floater angle is found by taking half the sum, so I'm going to add 2 arcs, the sum of its arc plus its vertical angles arc. Okay, so it's half the sum of its arc and its vertical angles arc. So let's go back to that floater angle I just picked, angle DCE. That would be found by taking half of its arc. What arc belongs to DCE? DCE is drawn to what arc? Arc DC, plus, now look at its vertical angles arc. So DCE is the angle. The vertical angle would be ACB. And what arc belongs to ACB? AB. So that is how I'm going to find a floater angle right now. All right, is by taking half the sum of the arc it belongs to and the vertical angles arc. Okay, so we're going to start lightweight and then get up to heavyweight, beefy problems here. Okay, so on number 1, we're assuming that is, I'm going to tell you, I'm not going to assume, I'm going to tell you that right there where X is not the center. It's floating in the circle. All right, so what I can do is take X, since it's a floater angle, I'm going to take 1/2 its arc, 88, plus its vertical angles arc, 86, and take half of that sum. Now, why are you going to the calculator right now? 88 and 86, you're taking the average of them, right? What's in between 88 and 86? Come on, honors kids, you're better than that. One job. One stinking job. All right, moving on. Now I'm given that the floater angle is 65. What's the arc measure now? All right, so 65 is the floater, and that's equal to 1/2 its arc, 100, plus its vertical angles arc, X. All right, now before you get crazy, a couple ways we could solve this algebraically. Yes, you could distribute the 1/2, okay, and do it that way. Me personally, you're not going to see me distribute the 1/2. So I don't want to deal with fractions, guys, honestly. If I don't have to deal with a fraction, I don't want to. So what I'm going to do instead, you'll see me multiply both sides by 2 because that gets rid of the 1/2. All right. And if you want to distribute the 1/2, feel free, kids. So that leaves me with 100 plus x. And on this side, I have 130. Move the 100 over. That arc, missing arc, x is 30 degrees. Okay? All good? 30 degrees. Moving on. Ooh, here we go. Now we're getting up to the beefy category of problems. Arc ABC to CD to DFG to AG are in a ratio of 2 to 3 to 1 to 4. All right, we know the deal. We know the deal. All right, we usually put x's with the ratios, but since I'm finding the value of x, is everyone all right if I put y's with them? Okay, so ABC is 2y, CD is 3y, DFG is 1y, and GAG is 4y. And I'm looking for x. Well, if I use my floater theorem, x should be equal to 1/2 of arc ABC plus arc DFG, according to my floater angle theorem. Now, all I need to do is find those arcs. Now, any way you can think of how to find what each arc measure is. Well, don't I know info about all of them? And what do all of them total up to? All of them total up to 360. So you have 2y plus 3y plus y plus 4y equal to 360. So now you can solve for y, plug it back in, and we're on our way. All right, so I have a total of, looks like, let's see, 5, 5, 10y equal to 360. So y equals 36. Okay, so let me go back. So this is going to be equal to 1/2. ABC is labeled as 2y, so 2 times 36 is going to be 72. Plus arc DFG, which is just labeled y, so that'll be plus 36. So that'll be equal to 1/2 of 108, which is equal to, I believe, 54 degrees. Okay, so again, you're going to see this a lot now. Numbers in a ratio, we put variables with them, whether it be x's, y's, z's, whatever you feel like. All right, now your first, look at that diagram. That is huge. All right, intimidating. Number 4, multi-part circle questions. Big dog circle questions. Big mama circle questions. Beast mode circle questions. I've had a lot of students call them different names. All right. Maybe during the next Google Meet, we can come up with our own name for multi-part circle questions. Here you go. Make sure we have this concept down. The key to success on these multiple part circle questions is the following. Find the arc measures. If you know what the arc measures are, you guys are on your way. Find the darn arc measures. If you know the arc measures for all the arcs, you're in good shape. Okay, you are in good shape. Okay, so let's try to do that. So AEH, from A to E to H, follow the letters in that order. That's $110. So A to E to H, right there. That's 110 degrees. AG is 80 degrees. And the ratio between AE and EH is 2 to 3. Again, I'm going to put X's with them now. So AE is 2X, EH is 3X. Okay? All right. Here's what I'm going to, again, preach to you. Find the measures of the arcs first if you can. I could care less what they say up here. I'll worry about that in a minute. I want to get every single arc I can possibly find here before I start this problem. All right. So finding your help here. Need your help? How can I find each arc measure? Well, let's start with AEH. It's 2x and 3x, and they add up to 110. So first thing I'm going to do is I'm going to say, all right, 2x plus 3x equals $110. 5x equals $110. So x is going to be equal to 22. All right, x is 22. So if I go back and plug it back in, 2 times 22, that's why it's nice to do these in pencil if you have it. That's going to be 44 degrees. 2 times 33, that one's going to become 66 degrees. So I have those two arcs. Can you find the rest of the arcs? All right, now if you take a look, what arcs am I missing? I'm missing arc G to B, and I'm missing arc B to H. Okay, look for diameters. Does everybody see AOB in the diagram? Look at AOB. That is a diameter, which means it creates two semicircles, which total how many degrees, kids? 180. So I can find the rest of the arc measures. GB is going to be 100. Because from A to G to B, that's a semicircle, which is 180. So that's got to be 100. And the same thing on top, AEHB. Look at that arc. AEHB, isn't that a semicircle? So that should total 182. And I already know that's one arc is 44 and the other is 66. So the rest should be, I'm going to have to go, I'm shamed here. 180 minus 44 minus 66 is going to give me 70 degrees for that arc. Okay, now that you've found the arc measures, now we can talk business here with parts A through E. All right, hopefully this will go smooth now. Let's find out. Okay, so for part A, says, what's the measure of GB? Oh, we found it already. Hey, there's a benefit to finding the arcs first, 100. Part B, what is the measure of arc EA? Oh, hey, we found it, 44 degrees. This is going pretty quick, huh? All right, now we got to do a little work now. Angle EFA, take a look. EFA. Okay, I'm going to go through this. This is going to sound like a broken record. I do not care, but this is what I need you to go through your head every time. Everyone take a look at EFA. I'm going to ask you 3 questions right now. EFA, is it a central angle? No. EFA, is it inscribed? No. So the only thing it could be is a floater angle. All right, it's got to be a floater angle. So theorem, 1/2 its arc, 44, plus its vertical angles arc, 100. A half of 144, 72 degrees. Okay? So go through those questions. Central inscribed floater. Central inscribed floater. All right, next, D. FEB. FEB. Here we go. Central. Nah. Inscribed. Oh, yeah, buddy. Because take a look where E is. It's on the circle. So FEB, go back. What was the rule for inscribed angles? It's going to be half the arc measure. So let's see. Where is this arc going to? It's going to an arc of 100. So it's going to be half 100, 50 degrees. Okay? I should also mention while we're doing this, as you find these angle measures, I would prefer you write them into the diagram. So what I mean by is, okay, we just found EFA. EFA is 72. And angle FEB was 50. Because you never know. You may need them down the line. All right, you can't remember a rule, but maybe you know linear pairs or supplementary vertical angles are congruent. All right, so write them in your diagram. All right, and then finally E, which is angle OHD. Ooh, Let me highlight that sucker. OHD. OHD. Is it central? Nah. Nope. Inscribed. Well, it's on the circle, right? But the other two sides aren't chords. So that's a problem. I can't do inscribed angle there. And it's certainly not a floater. So am I stuck? Am I stuck? I don't think so here. Because look up in the directions. It says DC was tangent to circle O at H. All right, so this is a tangent line. And what's OH? That's a radius. Theorem, 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 theorem. Radius drawn to a point of tangency is perpendicular. So no algebra needed here. That bad boy is 90 degrees. Okay? So I don't know what you thought about that one. But as we know, one doesn't make us great. Let's go to this one right now. Okay? And then we're all set for today. All right? Okay, accompanying diagram. We got a tangent line. Perfect. Ooh, got numbers in a ratio. Here we go. Let's set it up. ACB. A to C all the way to B is 4x. Oh, those are angles, not arcs. One job, boss. Come on, you're better than this. The angles. Got it. Got it. All right. Angle ACB is 4x. Angle CAB. This whole angle right here is 3x. And ABC is 2x. All right, here we go. Is there anything I can do with those three angles? Yep. We can add them up and set them equal to 180 because there are three angles in a triangle. We're good there. So that gives me 9x equals 180. X equals 20. So let's go back and put the actual angle measurements in now. So angle ABC was 2x. So that's going to be 40 degrees. Got it. Next up, I got the 3x angle. So 3 times 20 is 60. So that angle right there is going to be 60. And then I have the 4x angle, and that should be 80 degrees. Okay. And it looks like if you take a look real quick before we get into the actual problems, all three of those angles are inscribed, aren't they? The 40, the 80, and the 60. They are all inscribed angles. So we know if ever I need to find the arcs, I can double it. Okay, so let's go. Angle ABC first. Angle ABC. Found. Done. Angle ABC should be 40 degrees, right? Okay, next up, the measure of arc BF. Okay, let's see. BF, this one right here. Whew. All right, let's take a look. Arc BF. How can we find arc BF? All right, well, let's go back to the fact that these were inscribed angles. And again, if you can't find what you're looking for right away, try to find some other pieces that may lead to that. All right, watch what I'm talking about right now. All right, so everyone see my 80-degree angle, ACB. That's an inscribed angle, and it's drawn to arc AB. So if that's 80, the arc must be $160, right? I'm just trying to fill in parts of the diagram that may help me get to arc BF sooner or later. All right, remember the 40 we had. Angle ABC was 40. That's an inscribed angle, so its arc must be double that. That must be 80 degrees. Everybody good so far? No issues? Okay. And then let's see. We got 60 here. So doubling that, that would give me 120. But for arc BFC is 120. So from here to here to here is 120 degrees. Got it? Okay, let's see where else we can go here. I'm trying to figure out. Let's see. 160, 80, 120. Arc BF. I just don't want to assume it's going to be split in half. Oh, yes, I can. I don't need to assume that because, hey, reading the directions is important nowadays, huh? AP bisects angle BAC. All right, angle BAC is getting bisected, so we can assume that that's 30. We double it, and we get 60 and 60 there. Whew, reading the directions. And finally, how about the measure of angle BEP? Okay, where's BEP? All right, here's BEP. Get another different color out here, purple. There's BEP. Not central, not inscribed. It is a floater. So it's going to be 1/2. What's the measure of its arc? BEP belongs to an arc of 60 plus its vertical angles arc, which is an arc of 80. So BEP is going to be half of 140, 70 degrees. Okay? So again, even if it's not asked, find a piece of the diagram, an arc especially. Remember, if you know the arcs, you're in good shape for these multi-part circle questions. All right? All right, get after it, guys. We'll talk at the next Google Meet.